Today's communication systems are the product of extraordinary engineering, physics, and innovation, but they were built with different priorities: bandwidth over security, speed over resilience, scale over survivability. That design trade-off creates exposure. These systems rely on an open radio spectrum, predictable satellite orbits, centralized data centers, and physical fiber routes that can be monitored, interfered with, or physically severed. In military environments, signals can be jammed by overwhelming the spectrum, degrading link quality, or denying access to operational frequencies. Satellite communications can be disrupted by interference at ground stations, signal spoofing, or relay vulnerabilities. In space, solar storms, radiation events, orbital congestion, and adversarial interference can degrade satellite performance or interrupt coverage. On the ground, natural disasters, cyber attacks, and infrastructure damage, including fiber cuts, can remove entire communication layers in minutes. The more advanced our systems become, the more exposed they are, and when a single layer fails, communication doesn't degrade gracefully, it breaks. When the sky is unreliable, when the air is contested, when visibility disappears, what's left? This is the problem SeismicComm was designed to solve.
SeismicComm is a ground-coupled communication platform that transmits digital information using controlled mechanical wave propagation. Engineered vibrations that move through solid terrain, seabed environments, and physical infrastructure. Deployment is fast and flexible. Nodes can be anchored directly into the ground for rapid field setup, or buried below the surface for maximum protection and low observability. Once deployed, the system couples directly into the surrounding medium, allowing earth, rock, concrete, and subsea terrain to become the transmission pathway. At the transmission layer, digital data is converted into structured vibration patterns that are physically injected into the environment instead of broadcasting energy into open air. SeismicComm moves information through the physical world itself. At the same time, the system is continuously listening. Receiver nodes monitor the surrounding vibration field in real time, not only to detect incoming communication, but to observe environmental activity, structural movement, and surrounding signal behavior. This allows the network to communicate while maintaining situational awareness of the physical domain it operates within. Intelligent processing separates usable communication signals from background noise, whether that noise comes from natural terrain movement, industrial vibration, ocean dynamics, or environmental interference. The decoded data is then reconstructed and forwarded across self-routing ground-coupled mesh network, enabling information to move across land, between land and seabed infrastructure, and through environments where traditional communication cannot operate. And this is where the advantage becomes clear. By operating through physical transmission paths instead of exposed airspace, SeismicComm avoids many of the weaknesses that affect conventional systems. There's no reliance on satellite availability, no dependence on line of sight, no open radio spectrum waiting to be jammed. The environment itself becomes part of the protection layer. Earth, terrain, and seabed materials naturally shield signals, reduce interference, and make disruption significantly harder. In simple terms, instead of competing in crowded airspace, SeismicComm moves critical communication into physically stable channels. Quieter, more protected, harder to interfere with, and far more resilient. That's not a workaround. That's the foundation of the system.
At SeismicComm, we don't treat the environment as an obstacle. We treat it as a partner in the communication process. We design systems that work with the ground, the seabed, and the structures around them, learning their behavior, adapting to their patterns, and using those characteristics to carry information more reliably. The result is a hardened communication network that doesn't just survive its environment, it adapts to it and strengthens because of it. We took what was once dismissed as noise and what was once ignored as unusable medium and turned it into a resilient foundation, a physical layer, a reinforced pathway, a fortress built from the very environment that carries the signals you can't afford to lose. That's SeismicComm.